All right, so this problem reads, how much gravitational potential energy relative to the ground on which it is built is stored in the Great Pyramid of Cheops? Given that the mass is about 7 times 10 to the 9th kilograms, that's not written real well on that screen, sorry about that, and its center of mass is 36.5 meters above the surrounding ground. Then it asks us to compare that energy with the daily food intake of a person. So how much energy any one person takes in as a result of the energy they expended in a day. So this is a gravitational potential energy problem. And we know that our relationship for gravitational potential energy is the mass times g, 9.8, times the height. So if we look at what we're talking about with this pyramid, the height we're going to care about is that height of its center of mass. And we're told that is 36.5 meters above ground. So we can use that information then to calculate our potential energy. We're given a mass of 7 times 10 to the 9th kilograms times our g, 9.8, times our height of 36.5 meters. And when we calculate that out, we find that the potential energy of this pyramid is 2.5 times 10 to the 12th joules. So that's its potential energy. That's how much energy had to be put into it to have it sitting as this structure at that height. So how many calories does that compare to in terms of an average intake of a person? Well, if we look up the average caloric intake of a person, we found that the energy of eating for the daily average is about 12,000 kilojoules per day. So, if that is accurate, and we want to take the ratio of the energy needed to build the pyramid relative to the energy intake of a person, then, and of course there's the energy, ultimate net energy of that pyramid, we're going to take our 2.5 times 10 to the 12th divided by 12,000 kilojoules, so 12,000 kilojoules, I think that's the right number, kilojoules. This is just in joules, so those units aren't matching up, but you can do the 12,000 times 10 to the 3rd joules. So we can do it that way. We find that it is 2.1 times 10 to the 8th times more energy that pyramid has than one person takes in a day. That means it took a lot of persons in order to build that pyramid, or a lot of days, actually both. All right, so just practicing that gravitational potential energy equation. Good job.